Okay, guys, so all right. So, if you any questions, we should go over. That second page wasn't so good.
I don't like this.
The first page wasn't very good.
Yeah, it was. That's not good.
Which equation was it?
The full. That's what we did. Yeah, there he is. You're such an idiot.
All right, guys. So let me tell you my plan here for, because we're technically done learning new things for this unit, but at the same time, I didn't necessarily want to review for 2 whole days. So if we kind of spend more time talking about this, maybe have some chances to work on some of these types of problems again a little bit more, and maybe give you guys the review today to start on, and then review tomorrow and test on Thursday. So, okay. So that gives us like kind of a day and a half-ish of, I mean, I guess it's really 2 days of review because we're not learning anything new. So that way, if you guys need help, just understand that there is time to come get help, not tomorrow because of AR is ACP, but Thursday you're welcome to come in during AR if needed. Or just asking when we have time to work in class. We'll have kind of big chunks of time with us having review time to work on review assignments, but then also on your note card. Just a reminder that we are not using calculators on this test unless you want to use just a scientific, like if you have a hard time, I don't know, doing fractions or something like that, you could use a scientific calculator, but not a graphing calculator. Graphing calculators just have too many capabilities, so I'm fine with a regular calculator, just not graphing. Is that okay? Yep. All right, let's talk about these then. Now, if you guys would like to, I'm probably like if you're like I am. All these four were awesome. I don't have any issues with them. You can work on the last 2, like 7 and 8. That's probably going to be our, like, we'll probably talk about those in a little while as well. So if you want to look at those, and then I'll get you guys the review in a little bit. But let me pull this up so we can look at it together.
Yesterday, I'm looking like, bro. He said that? Yeah. You don't get Lou heard it because he was loud.
Bro, that's not how you encourage your teammates or players to play.
He's like,
All right, so guys, again, if these went 100% fine for you, feel free to work on the last 2, which are numbers 7 and 8. If you don't need to go over these, however, I would highly suggest you guys going through these with us. Now, there wouldn't be like 4 of these on a test, probably 1 question that has like a word problem with it. And it's really breaking out this information and kind of figuring out what we need. So again, before you guys left yesterday, we talked a little bit about what a steamboat looks like. It's like a paddle boat kind of. And so that's a circular motion. So that's the idea of that period and that repeats. So it says, as the paddle wheel turned, a point on the paddle blade moved, so the distance d from the water's surface was a function of time. When his stopwatch read 4 seconds, first of all, I'm guessing, well, maybe Mark Twain had a stopwatch. I'm picturing like a digital stopwatch, but probably.
That's what I'm thinking.
But no, probably just a
Regular
regular watch, but they had stopwatches. When his stopwatch read 4 seconds, the point was at its highest, 16 feet above the water's surface. So we found out the maximum is 16. So that helped me to determine that I'm going to go up by 1s up to 16 for my scale. So my maximum is 16. So I'm going to mark that on here. And it's after 4 seconds, And then they talk about, so I think across the bottom, I went every value as well, I guess. So, so this is 2, 4, 6, 8, 10, 12, 14, 16. And then across the bottom, 2, 4. So my first point at 4 seconds, it was at 16 feet above the water. So there's our highest point. Now we know it'll go back up to that point again. This is a circular wheel. And so at the highest points at 16, it's going around, and then however many seconds later, it's back at 16 again. So that's what we have to figure out then. It says the wheel's diameter was 18 feet. So that's high to low. So if we're picturing this again, so it's up at 16, but then they tell us the diameter is 18. So that means it's actually, which makes sense, it's underwater 2 feet. So it should go negative, and I apologize, our graph didn't have much space for negative, but it's not like you need this perfect, like graph drawn, but so the lowest it's going to be is down to -2, but it says it completed a revolution every 10 seconds. So 10 seconds, we're back up to 16 again. So I have to go all the way to 14 seconds to know that I'm back up at 16 again. So 6, 8, 10, 12, 14, 16. No, 14, we said, right? At 4 seconds, so at 14 seconds, we're going to be back at 16 again. So 14, back up there. Now, in the middle of that is where I'm going to be at my lowest point, and we decided that lowest point is going to be -2. So I have to find the midway between 14 and 4. What's the halfway point between 14 and 4? It'd be 9. You add them together, divide by 2. So that'd be 9. So 6, 8, 9. So down -2 down here somewhere. Now you guys don't forget what you guys know about sine and cosine graphs. You should know that like the halfway point between those two then should be at the 0 line. So what we're going to do now is I'm going to try to find that midline. So down to -2 up to 16, that's 18 apart. So 9 from each way, we're going to have a midline. So it's 7, 2, 4, 6, 8, 7. This is the midline of my graph. Now, in between there, it should hit, so we're at, we said this was at 9. In between 9 and 14, we should hit this line. In between 4 and 9, we should hit that line. So we're going to try and draw this as best we can as a curve. And there's our cosine curve is what I think it looks like. You could use sine if you wanted to. I use cosine. If you have questions about what your sine graph would look like, I'd be glad to show you that. But since this is what we have drawn right now, cosine just seems very obvious to me. So it says, what's the lowest value? So it goes down to -2. Why is that reasonable? Reading from the problem, again, if that was something you were like, I didn't know anything about what that looked like, that's why I kind of talked about it ahead of time. So in order to paddle, it's gotta hit the water. I mean, it's gotta go under. So now they want the equation. So again, I use cosine, but it's up to you guys. So we have to first find the amplitude, because we're doing A cosine bx minus c plus d. So we need our amplitude. So that's how high and low it goes. So that's this distance here. And I believe that's going to be 9. Up 9, down 9. I'm going to write it down here. Now I have to figure out my b value. And that talks about the period. So the period is 10. And we have to find b, so that's 2 pi divided by b. So I'm going to have to cross multiply. So I find out my b value is going to be 2 pi over 5. So when I do this, I get 10b equals 2 pi divide by 5, or divide by 10, sorry. I'm thinking of the answer already. So my b value is going to be, pi over 5, simplified. Now normally cosine should start at 1, 0, or the amplitude, or 0, 1, or 0, whatever the amplitude is. So technically, this one should start at 0, 9, if like we were talking in general about our cosine graph. So 0, 9 would be like right here, because it goes up 9, down 9. So that would be where it normally would start. So we have to move it over and then up. So we go over 4 and then up, is that 5? 7, sorry, up 7. So I went to the right 4, so that's going to be a -4. And then up 7 to where we need to start from. And then it says, how far above the surface was the point when Mark's stopwatch read 7 seconds? So you're just trying to make an estimate, or 17, sorry. So here's 16, here's 17. So I'm trying to figure out about where that would be, and you're just trying to like kind of estimate that maybe. And maybe I didn't have, I had about 3 feet on this one, but I could argue that maybe it should have been steeper. I don't know. It just depends on your graph and your estimation. Okay. So let's look at our next one here. So John's floating in a wave, tube in a wave pool. So if you've ever seen a wave pool, the waves come through. And there's times where you can touch the ground, and then there's times you can't touch the ground. Yep. So the waves go up and over your head. But he's floating, so he's going up and down with the wave pool. And kind of waves are kind of a nice way to think about this because they follow that shape. So his height varies with time. At 1 second, John reaches a maximum height of 14 meters above the bottom of the pool. At 9 seconds, he reaches a height of 2 meters above the bottom of the pool. So he never actually is like sitting on the bottom of the pool. That would be a lame wave pool, but it gets down to 2 meters. So at 1, he's a max. So again, across the bottom, I go 1, and then I'm going to go up to 14. 2, 4, 6, 8, 10, 12, 14. So 114, I'm going to use X's to make it easier. And then at 9 seconds, he's at 2, 3, 5, 7, 9. He's at 2 meters. So if that's all they told us, when is he going to be back up at the top again? If this is like an ongoing forever wave pool. So this is a distance of 8, so we need to go 8 more. So at 17 seconds, he's going to be back up at the top again. So again, 11, 13, 15, 17? Or did I count that wrong? Okay. So 17, we should be back up here. So again, his curve it says that the wave machine's turned off. How deep is the pool? So it's not making waves at all. That's just like our flat, no, it's not being 2 meters, there's all that water still in the pool. So it gets shallow, it gets big, it gets shallow. So the middle line is going to be like the resting height. So we have to figure that out. So it goes from 2 to 14. We're finding the halfway point between those. So it would be 8. This is a pretty deep wave pool. Don't throw just anybody in here. So 2, 4, 6, 8. Is that the halfway point? Yeah. So 8 meters there. multiply y is on a 2, so you can drop. So, so if there's no fluctuation, just be flat there. That's no waves. What is John's height after being in the wave pool? Oh, we're supposed to write the equation. So 5 seconds, 15 seconds. So again, this is kind of supposed to be an estimation, like what we're at. But 5 actually looks like kind of a nice number. It looks like 8. And then 15, 11, 13, 15 is somewhere up here. So mine looks like 11 there. I had 12 on my sheet. It just kind of depends on your curve. Now again, in my opinion, this looks like a cosine. So distance here is 6. Now, the time, we decided that was 16 seconds, right? So from high to high, it's 16, so that's our period. So we have to set 16 equal to 2 pi over b. So cross multiply, we're going to end up with pi over 8, bless you. Now again, my cosine graph should normally start at 0 and then whatever the altitude is. So this should be 0, 6 it should start at. And so it moved over and up. So over 1 and then up. Oh, I didn't write the equation on here. Over 1 and then up, what is that? 8? So minus 1 plus, it goes from 6 to 14. So something like this will be on your test. Again, there won't be a lot of them, like be able to do one question and answer questions regarding that. I'll give you some points. I'll give you, you know, like the start and end, or I'll give you the max and min, kind of giving you that information. Yes?
So when you're trying to find a point on the graph, you don't plug in the numbers, you just guess where it is?
I think it's better to guess. I mean, plugging them in could be a big pain. I mean, so yeah, a good guess, and like just showing me where you think that is based off of your drawing. So like Emma's question was, like, do we actually have to substitute these values in? You don't need to. You can just kind of say that's what it looks like on my graph, and I might, you know, like, this might be a place where I say, well, your graph was really, really bad. I mean, I think long as you're trying to draw a curve, I'm fine with it. Because depending on, I think in the past I've done it, it fit perfectly, and then other times it was further off, so it just kind of depends. All right, let's look at number 4. So I don't know if you guys saw this direction, but this one tells us to use in the, down here it says this is a sine function, or they want us to use a sine function. So if that's the case, I'm going to kind of draw where my typical sine function looks like it's rolling here, because it goes, it doesn't look like it's shifted up or down at all, because it goes up to 2, down to -2. So I don't think there's any vertical shift there, and it actually doesn't even have a line for it, but so to me that's just probably our curve we're looking at. So our amplitude is 2. Now the period goes from 0.25 pi to 2.25 pi. So our period is normal, right? So 2 pi. And then our shift, it's supposed to start at 0, 0, so this moved over 0.25, and that would be right, it moved over if you're using sine. And then all we have to do is put that into our equation then. It's just like, you can either go, you can do a couple of things. So since I can clearly tell this is the start and this is the end, I kind of subtracted those two. Otherwise, you could go like max to max and check those.
Oh,
you know, like that's kind of a safe way as well if you can't tell where the middle is. But this one, the middle seems kind of obvious to me, but it might not be obvious to everyone. You can always use a piece to help you. Yes? Because the sine graph doesn't start down, it has got to start in the middle. So you're taking a sine graph. So if I have a sine graph that looks like this, sine graphs have to start here, end here. They have to start at 0, 0, then go up to their max and down to their minimum. You're saying it's starting like here. So you're like changing the starting spot. So sine graphs have to start like that, whereas cosine, I have this, cosine has to start at the top and end at the top, where sine has to start in the exact middle and end in the exact middle. So if you're starting down here, your amplitude going this way is different than your amplitude going. You have to find the exact middle. Or the exact bottom. So if you wanted to use cosine, you could have started on the bottom down here. All right, so guys, why don't you guys take some time to work on 7 and 8 if you haven't already? If your 7 and 8s are good, then I might just give you guys a review to start working on. But if you guys can start looking at 7 and 8 on this worksheet and give you guys a little bit of time to try that, notice that 8 asks you to use a sine graph. And on the months, I would call the months like by their numbers. So I'd call January 1, February 2, March 3, if that makes sense.